In the name of Almighty Allah, the most merciful and the most beneficent, well, students, welcome you all in this session 3 of week 3. As you all know that we are going through unit 1, that is physical quantities and measurement. In the previous sessions, we discussed about physics, branches of physics, physical quantities, base and derived quantities, units, prefixes, scientific notations, and two main measuring instruments, that is meter rule and measuring tape. In this session, you students will be able to describe and take measurement by using Vernier calipers. It's a new measuring instrument, and this measuring instrument is very important part of measuring instruments, because by using this measuring instrument you people can easily calculate the lengths of different objects, small diameters, small thickness of a wire. And in the pictures you can see that different Vernier calipers, these two are manual, you can say these are the simple Vernier calipers, and the third picture, this one, is basically a digital Vernier caliper. You can see digits will show you the diameter or thickness or whatever you will find. This Vernier caliper, this digital Vernier caliper is more precise than these two because it's least count. We will discuss it later at what is least count. Least count is basically the smallest reading which any instrument can take. So this Vernier caliper is more precise as compared to this Vernier caliper, but the method of taking measurement is same in all these. Like this digital Vernier caliper will show you the digits, and in this you have to find. In our laboratories, these types of Vernier calipers are mostly used. Now come to the major subtopics which we will discuss in this session. First of all, we will discuss about the parts of Vernier caliper. Then we will discuss how we will find the least count of a Vernier caliper. Then we will discuss that how you can measure or come through the how you can judge or calculate the errors in an instrument if an instrument has. And in the end we will discuss in detail that how you can take measurement by using Vernier calipers. First of all, come to the parts. As in this picture, I will start from the left top corner. You can see these two jaws. These two jaws are called inner jaws, and these two jaws can be used to measure the internal diameters of some specific cylinder or test tube or whatever. Like in this third picture, you can see you can see there is a cylinder here, and these are the two internal jaws or inner jaws which are used to measure the internal diameter of this beaker. Now come to this one, screw clamp. When you will place something here, then you can tight it so that the jaws may not open more. These are the outer jaws. These outer jaws are used to measure the outer diameter or the diameter of a sphere or the diameter of any beaker, external diameter, outer diameter. These outer jaws will be used. Very important, the Vernier scale. This is a Vernier scale here, the pointer. This is the Vernier scale. Second thing, main scale. This, I'm putting a line over a main scale. This whole scale is a main scale. This is the main scale. Fine. And this one, the stem. This stem is used for the measurement of depth. Here in picture 2 you can see it. By putting this into a beaker, you can measure the depth of a beaker. You can measure the depth of a beaker. These are the main parts. I'm repeating it: inner jaws, outer jaws, screw clamp, vernier scale, main scale, and the stem. These two are very important: vernier scale and main scale, because our reading is and our least count is totally based upon these two scales, vernier scale and main scale. Keep this thing in your mind. Here in the fourth picture you can also see the vernier, the man is measuring the internal diameter of this bottle cap by using upper jaws, or you can say inner jaws. Now come to the next slide. Here, the least count. How you can calculate the least count of a vernier caliper? Students, keep this thing in your mind. The formula for least count, for measuring least count of a vernier caliper, is smallest reading on the main scale and number of divisions divided by number of divisions on a vernier scale. When you will divide, or when you will take a ratio between smallest reading on the main scale and the number of divisions on a vernier scale, then you will come to know about the least count of that particular instrument. Whenever you will hold a vernier caliper in your hand, first of all you have to see the smallest reading on the main scale. As you see that I'm putting a line on the main scale, this is a main scale, and this is the main scale. You can see it. I am writing MS for main scale. This is the main scale, and here you can see this main scale is in centimeters, from 0 to 1. From 0 to 1, here it is 1 centimeter, here it is 2 centimeter, and here it is 3 centimeters. Fine. Now from 0 to 1 there are 10 divisions: 1, 2, 3, 4, 5, 6, 7, 8 and 9, until 1 there are 10 divisions. So smallest division is equals to 1 millimeter. From 0 to this division it is 1 millimeter, and you know in 1 centimeter there are 10 millimeter. The smallest reading in the main scale is 1 millimeter. So I write the smallest reading in main scale is 1 millimeter. I hope you got the concept. Now come to the divided by number of divisions on vernier scale. This is your vernier scale. This one is your vernier scale. And how many divisions on the vernier scale? There are from 0 to 10. There are 10 divisions on vernier scale. So here number of divisions on vernier scale, it is 10. So when you will divide 1 divided by 10, you will got the answer 0.1 millimeter or 0.01 centimeters. If you will convert 0.1 millimeter into centimeters by dividing it by 10, you will get the answer 0.01 centimeter. So I hope this one, I'm repeating, this one is your vernier scale VS, and this one is your main scale. So smallest reading on the main scale divided by number of division on vernier scale equals to 0.1 millimeter. Mostly vernier calipers has this least count, but whenever you will take an vernier caliper in your hand, you must have to calculate the least count of an instrument by using this formula. Now come to the instrument errors. There are 3 types of errors which any vernier caliper may have. It may have such type of errors. First of all, see this first picture. This, by joining the jaws like this, as you know that there is nothing inside the jaws. When you will join the jaws and the 0 of vernier scale, if the 0 of vernier scale coincide with the 0 of main scale like this, if the 0 of the vernier scale coincide with the 0 of the main scale like this, then this means there is no zero error. No zero error. And if by joining the jaws, as you know in this picture, 2 jaws are totally combined with each other, jaws are joining with each other, but here the 0 of vernier scale is not coinciding with the 0 of main scale. As you know, this is a main scale and this is a vernier scale. This one is a vernier scale. The zero of the vernier scale is not coinciding with the zero of the main scale. Here there is an error in an error. Here there is an error in an instrument. And what we will say that what type of error in it? As zero of vernier scale is on the right side of this zero. Zero of the vernier scale is on the right side. You can see here you can see the zero line of vernier scale is on the right side of the zero line of the main scale. So this is a positive zero error. This is what positive zero error is. And if by joining the jaws, zero of a vernier scale, this one is vernier scale and this one is main scale. As you know that zero of the vernier scale, after joining the jaws, the zero of a vernier scale is on the left side of main scale. Zero of the vernier scale is on the left side of main scale. Then this will be a negative zero error. Sorry, this one, negative zero error. Negative zero error. We can raise it here. Yes, negative zero error. This is negative zero error. When vernier scale zero is on the left side of zero of the main scale, then this is negative zero error. And this is your picture 3. And when the zero of the vernier scale is on the right side of the zero of the main scale, then this is positive zero error. This is your second picture. And when on joining the jaws, the zero of the vernier scale is totally coinciding with the zero of the main scale, then this is your main scale and the yellow one is your vernier scale. Then you can say that this is instrument is having no any zero error. Now come to the next. In the previous slide we discussed about least count, and in this slide we discussed about the errors of instrument. Now boys and girls and my dear students, this slide plays a very important role in the understanding of the measurement which you can take by using vernier caliper. So you have to be very vigilant and very much attentive in this slide. How you can take measurement by using vernier calipers? There are 3 main steps for taking measurement. Whenever you want to take measurement from vernier caliper, first of all you have to find whether the instrument is having any zero error or not. First of all you will find it whether the instrument is having any zero error or not. How you will find it? I told you this thing in the previous slide, that if the zero of the vernier scale is on the left hand side, then it will be a negative zero error. If it will be on a right hand side, then it will be a positive zero error. And if the zero of the vernier scale is coinciding with the zero of the main scale, then there is no any zero error. Here you can see 2 pictures here. First picture, in the first picture you can see there is nothing inside the jaws. The jaws are totally combined with each other. Here I am telling you about how to take measurement by using these 2 pictures, this one and this one. These 2 pictures, by using these 2 pictures I will explain you people. First of all, what we will do, we will join the jaws like in this picture. There must not be anything inside the jaws. Then you will see whether the zero of the vernier scale is coinciding with the main scale. Here you can see the zero of the vernier scale is not coinciding with the zero of the main scale. The zero of the vernier scale is on the left hand side, so it is a negative zero error. Keep this thing in your mind. First of all you have to clear this concept. This is a negative zero error. Now error is 0. Now it is an error. So how we can make a correction of it? I will discuss it in this portion. In this portion, you can one main important thing I want to discuss here, that first of all you want to find zero error, so you must know about the formula. The formula for finding zero error is main scale reading and vernier scale reading. When you will add these two readings, then you will be able to get zero error. Whenever you will find zero error, main scale reading will always be 0. You can also take reading in millimeters, but it is more comfortable to take the reading in centimeters while using vernier calipers, because in your book, as we have to follow the textbook, so you will use the values in centimeters. While finding zero error, the formula is main scale reading plus vernier scale reading. Main scale reading while finding zero error will always be 0. Now, how you will find vernier scale reading? The formula for vernier scale reading is vernier division that coincide with main scale division multiplied by least count. Least count of what? Least count of vernier calipers. Vernier division that coincide with main scale division. In this picture one, you can, when you are confirmed that there is a zero error, then you will see that which division is coinciding with main scale division. Which division of vernier scale is coinciding with main scale division? Here you can see the vernier, 6th vernier division is coinciding. 6th division is coinciding with main scale division. Here you can see it. So according to the formula, vernier division that coincides with main scale division is 6. This one. Multiply the least count, and the least count of vernier caliper is 0.01 centimeter. As this picture is, I got this picture from the previous slide, so this picture is also having the least count of 0.01 centimeter. I just put the value here. 0.01 centimeter when get multiplied with 6, the answer will be 0.06. Here I forgot to write centimeters. You have to write units as well. 0.06 centimeters. And the main scale reading, as you all know, whenever we will find zero error, the main scale reading will always be 0. Vernier division, which vernier division is coinciding with it? 6th division is coinciding, so you will multiply this 6 with 0.01. That is the least count of vernier caliper. Then the answer is 0.06 centimeter. Here I put a minus sign because we know that the error is negative, as the 0 of vernier scale is on the left hand side. So I put a negative sign here. And what will be the zero correction? The opposite, we will just put an opposite sign with it. Or you can say the negative of zero error will be a zero correction. What is the negative of this one? Plus. You can say the negative of zero error. Negative of zero error. Here you can see the negative of zero error and what is zero error? Minus 0.06 is the zero error. If we take the negative of it, the answer will be plus 0.06. So make sure that whenever you will find zero error, the negative of that zero error will be a zero correction. Here is the zero correction, and we will use this zero correction in the end. Now come to reading. After finding zero error, you will place something inside these jaws or on the in the upper jaws, wherever you want to find. Then again you will take a reading, and for observed reading, again the formula is same. You will add main scale reading and vernier scale reading. And here you will see, for taking main scale reading, come to this picture 2. For taking main scale reading, you will see the 0 of the vernier scale. The main scale division which is behind or just coinciding the 0 of the vernier scale is the reading of the main scale. Here there is no any division of main scale which is coinciding with vernier scale 0. So the division which is behind this 0 division of vernier scale is the main scale reading. This is the main scale reading, and this is 1.1. centimeters. I hope you got the concept. Plus, again, vernier scale reading, how you will take it? You will again check which division is coinciding with it. Here 1 is not coinciding, 2 is not coinciding, 2.5 is not coinciding, 3 no, 3.5 no, 4 no, 5 no, 6 is little bit, and but exactly the 7th division is exactly coinciding with the main scale division. So I will write 7 here. 7 multiplied by least count. Answer is this 1.17. You got the observed reading. This is your observed reading, but you know there is an error in your instrument. So what you will do, you will add. Now you are going to take a correct reading. And what is the formula for correct reading? You will add this observed reading with zero correction. You know the zero correction is plus 0.06 here, you know, see it, and here the observed reading 1.17. When you will add these two readings, you will get the correct reading, that is 1.23 centimeters. So keep this thing in your mind whenever you want to take, now I'm repeating it, whenever you want to find zero error, the formula is main scale reading plus vernier scale reading. Whenever you want to find observed reading, the formula is same, main scale reading plus vernier scale reading. And whenever vernier scale reading formula is same in both formulas, vernier division that coincides with main scale division multiplied by least count, vernier division that coincides with main scale reading multiplied by least count. These two formulas are same, so please don't get confused with these formulas. If you will write these formulas for 2 or 3 times, then it will become easy for you people to learn these formulas. And the methodology, how you will take the zero error, how you will take observed reading, how you will correct it, I mentioned you in this slide. For your self-assessment, I'm giving you this picture. You will do it by stopping this session at your home, and you will find the reading. I hope you enjoyed this lesson. Thank you so very much. Have a good day.